Now, given this following chemical equation, of course, we are missing a couple of things, but most importantly, focusing on the reagents. What are we going to do in order for we to determine the following products? 3 products here are to be determined, and most importantly, we need to be able to recognize a couple of things in order for we to dive into this. This here is an amide, and this is going to be subjected to bromine and a base in the presence of water. And using these reagents, how we're going to be able to predict the products, and through a mechanism, couple of steps required, how we're going to be able to prove that indeed those are the products. So I encourage you to please pause this video, try it out, and see what reactions or mechanisms are required in order for we to determine the right product. And if you got the right product, and you come back and play this video and check out my mechanism, is there any differences or similarities with the mechanism? If so, if not, please jump down in the comment section and share your thoughts so that others can actually see your steps, and also a couple of ways that maybe the mechanism that I've shown can be proven properly right or not really. So let's dive into this. Now, some of you might recognize this particular reaction in terms of the reagent setup to be called a particular rearrangement, and this particular rearrangement is called a Hofmann's rearrangement. And why is this really important to recognize? The reason why this is important to recognize is because this will enable us to set up our end goal. Our end goal here is to go from a specific amide, which is actually shown as the reagent right here, to what? An amine. What type of amine are we going to be looking at? Is it a primary amine, is it a secondary amine, or tertiary amine? We're going to look at this as we move further down into this video. And most importantly here, this is going to come at a cost, and the cost is the loss of a specific atom, specifically the loss of a carbon atom. And this will be done in terms of one of the release of another product that will be established right here. So that is what Hofmann's rearrangement is. This rearrangement will be noticed in a specific step of the mechanism here that is somewhere around closer to the formation of amine, and this is going to be involved in a particular intermediate, and this intermediate is going to be addressed as we highlight the steps. So let's talk about the steps in order for we to start to the end goal, which is the amine. The steps are as follows. First is that we need to be able to start with the specific primary amide. And this primary amide is what we showed right here. And once we are able to address or recognize this, we are going to subject this primary amide to 2 things. One is going to be the presence of a base, and most importantly, bromine. And this here is going to be important in terms of how it's going to be a form of a treatment that will enable us to go from our amide to the next intermediate that I talked about, which is nitrene. And nitrene is really an interesting form of carbamine, and this is going to be important because it will be involved in a specific form of rearrangement that is quite similar to that of our Cordus rearrangement process, and you're going to recognize this as we show you that particular mechanism in one of the steps that are going to be shown in this video. So once this is done, the next step is to go from a nitrene to another intermediate, and this intermediate is called isocyanate. And this isocyanate is going to be subjected to a process that is called hydrolysis. This is going to be important because water will be involved in this process, and this will enable us to arrive at our final product, which is called amine. And these are the steps to remember, and we are going to use these steps in order for we to accomplish the end goal for this particular reaction. Now we're going to begin with the mechanism for this particular reaction, and we are going to showcase all the steps using all the reagents possible to arrive at our specific product. And so let's begin with the first step. Now these are the 3 steps. For step 1, we're going to look at the process which involves the base bromine treatment, and through this particular process we're going to begin with our reagent, which is called the amide. And once we have our amide that is in this particular reaction step, is going to undergo a specific type of base deprotonation, and what happens is that the OH negative is going to pick up a proton which is here, and that proton is going to cause the bond between the hydrogen and the nitrogen to become a double bond between the nitrogen and the carbon here, and this will lead to the double bond, which is the pi bond here, to form a lone pair on this oxygen. Therefore, this will lead us to the formation of this intermediate. Now, once this is achieved, the next step here is going to involve the presence of bromine. What this implies is that there is going to be electron movement that starts on the oxygen, with the lone pair becoming a pi bond, and this particular pi bond here between the carbon and nitrogen picks up this particular bromide, and this particular bond here cleaves to form a lone pair on this bromine, and this results in the formation of this particular product. Take note here that a bromide is going to be released in this particular step here, and this will lead us to the next step, where we're going to have a specific water particle that was formed here to be involved in another process called a deprotonation process, and therefore the water that is going to be present with the lone pair on the oxygen is going to pick up the hydrogen on this nitrogen, and therefore this bond cleaves and forms a double bond again with this carbon nitrogen. This particular pi bond forms a lone pair on the oxygen, and this results in the formation of our intermediate, where we have the oxygen double negative charge, and we have a double bond with the carbon and nitrogen. We just have one bromide present there, and we have our R group that is present right here. Now this leads us to another electron pushing arrow rearrangement, because we have a good leaving group that is present, and this good leaving group is bromide, and what results in is the release of this particular bromine, and what results in this is through this electron pushing arrow, where this lone pair forms a double bond here, and this particular double bond forms a lone pair on this nitrogen, and this results in the leaving of our specific bromide. Take note here also that once this bromide leaves, it will form hydrobromic acid, and what happens here is that we are going to have these to be formed, and once this is formed, this is our first product that is going to be shown right here as we move to this particular chemical equation. And so our first product that is going to be formed is hydrobromic acid. So that is something to keep in mind. And once we are able to recognize that, we are going to move on to forming our first key intermediate product. And this first key intermediate product is going to have a carbon with a double bond on the oxygen. We have our nitrogen, which has an interesting look on it, as we're going to discuss very soon, and our carbon is attached to the R group. This here is going to be called acyl nitrene. And this here is really interesting because the nitrogen here has just 6 electrons, which makes it to be electron deficient in this particular species right here. And therefore this subjects our acyl nitrene to be highly reactive because it is considered to be an electrophile. This leads us to the second step, and this second step is going to be a process that involves a rearrangement that is similar to what we did on our previous video, which focuses on the Cortez rearrangement. And in here, what we notice is that the acyl nitrene is going to have some specific sensitive areas. One is the nitrogen, of course, because it is really electron deficient and it needs electrons to be able to be stable. And in order to do that, this whole system or species will have the R group to be involved in that providing that electron. And in order for it to be accomplished, what happens is that we're going to have this bond pair from the R group to come in contact or form a bond with this nitrogen. And what happens next is that we're going to have this particular lone pair on the nitrogen to form a double bond between the nitrogen and this carbon. Therefore, this results in the formation of our next intermediate, which is a key intermediate, and this is familiar because it is indeed called isocyanate. And this is going to be important when we move this isocyanate to the next step. Now, this step of focus here is going to be involved in using water to change this isocyanate or transform it completely to our final product, which is an amine, and this is called hydrolysis. And through hydrolysis, we see that when we start first with water, please follow this because this is going to be important as we move from one step to another. What we see is that water was going to first come in contact through the oxygen with this particular carbon right here. Forming a bond with this carbon results in this pi bond to form a lone pair on this oxygen, and most importantly, the lone pair on this oxygen is going to pick up a proton, remember, from another water particle. This leads to the formation of this particular intermediate. Now, this here is going to be subjected to another water particle that is going to deprotonate this proton right over here. And so what happens is that we have water particles around, and we're going to have this particular oxygen picking up this proton, therefore forming a lone pair on this oxygen, and we are going to form this particular intermediate right over here where our R group is bonding to the nitrogen. Take note, we have a double bond between it and carbon, and we have 2 hydroxyls that are present right over here. Now, this next step is going to be crucial because we have 2 hydroxyls present right here, and something else is going to happen to this double bond right here. Take note also that we have one particular side product that is actually going to be formed, and this side product will be helpful in order for we to be able to accomplish this next step. And this next particular species is the hydroxyl that is formed right here. Recognize that once this hydroxyl is introduced, we are going to have something that is really cool in terms of electron pushing arrows. And what happens is that this particular hydroxyl is going to deprotonate one of these two hydrogens. In this case here is going to be whatever one that I choose, is up to me, and I'll pick this one, and therefore this results in this particular bond to form a double bond with this particular carbon and oxygen, and therefore this causes this particular double bond between the carbon and nitrogen to lose its pi bond, and this pi bond will be involved in the picking up of a proton from a hydronium that was actually formed right in this process over here. And so what happens is that once this is accomplished, we are going to have our specific intermediate that is going to have the losing of our double bond, and we're going to have our formation of a step closer to our amine, and this step closer is going to be shown right over here. And next, and almost and indeed the final step, is going to be really instrumental here, and this final step here is going to be involved the specific deprotonation of this particular hydroxyl here. And what happens is that we're going to have our OH negative hydroxyl to come in here, and the oxygen is going to pick up the proton right over here, which causes this particular bond here to form a double bond with this particular carbon, and therefore this particular bond here cleaves and deprotonates another hydronium, and this leads us to the introduction of our proton to the nitrogen that is present in this particular species right over here. And therefore we are going to see two things happening. One is a release of another important product that is going to be crucial here, and the release of another interesting product. And what happens is that this here is going to lead us to the release of carbon dioxide, and this is going to be shown right over here. And carbon dioxide is one of the important products that will be released, and we're going to highlight it right over here. And the other product that is going to be released is going to be called our primary amine, and this is shown right over here, where our group is bonded with the nitrogen lone pairs, and we have two hydrogens bonded to the nitrogen. And so these are the important products to keep in mind. We have our primary amine that is formed, we have our carbon dioxide that is formed, and we have finally, looking at this particular step, our hydrobromic acid that is released right here. So in this video here, we are able to determine the three products from these particular reagents that are provided in this chemical equation that is shown right here. And the most important product here to keep in mind is the formation of our primary amine, and this is through the process that is called a Hofmann rearrangement, where our amide is going to be our starting reagent in the presence of bromine and a base and water, and this will lead us to the loss of our carbon atom that is shown through the release of carbon dioxide, and this will lead us to the formation of our amine. I hope you found this video really informative. Please hit the comment down below. Let me hear your thoughts about your own reaction steps based on the mechanisms, and see whether there's any other way that you actually got to the same products like what we have right over here, right over here, and right over here. All the same, thanks for following me through this, really appreciate it. See you on the next video. Stay smart as always, and believe in yourselves.